Thanks, Manish. With that, let's begin. Um, I'm going to be talking about a project that we did where we embarked on building essentially a SIEM on top of OpenSearch. Now, I'll kind of bring in a whole bunch of background that I've collected along the way, building data management platforms, and then looking at cybersecurity, building products like this. Uh, Before I get in, let me quickly describe myself. So my name is Vinayak Borkar. I'm the CEO and founder of Mark 5 Software. I have Zach in the audience there. He's my co-founder at Mark 5. Yeah, as Manish mentioned, I've been in the data management space for a few years, for about 20 years now, and built a few companies in data as well as in the security space, and a bunch of open source projects. Um, what we're going to talk about today, I'll talk about SIMs. I don't know, just show of hands, how many of you have worked with SIMs, know what a SIM is? All right, that's a pretty good number. So I was going to cover what a SIM does and what the SIM has evolved into today, over the last decade or so, and then talk about security data lakes and security analytics, and then jump into how OpenSearch plays a role there, and what we are doing at Mark 5 to kind of help with this process. So as you know, SIM stands for Security Information and Event Management System. Traditionally, a SIM was a monolithic piece of software. Like, you would basically buy the whole solution from a company. Like in the past, olden days, it used to be, NetWitness and ArcSight, and then more recently, it became Splunk, and then there are a few others that have built SIMs. But fundamentally, SIM began its life in collecting a bunch of logs from security products, other products that produce logs, and basically giving the user the ability to correlate across these events, with the whole goal of providing visibility into the security posture of the organization. But then the SIM also started to become the one place where a whole bunch of security workflows kind of converge, right? So there is threat hunting where, uh, I'll talk about the different workflows in a moment, but the idea is it becomes a shared warehouse where a whole bunch of security analysts and security personnel do their workflows from. Now, over time, what has happened is that security analytics stack has become pretty complicated and kind of expanded into a whole bunch of different pieces, right? So what I have here is kind of the building blocks, if you will, that a SIM used to be made of, or still made of, but now it's kind of becoming disaggregated in some sense because of the complexity of this. So on the left hand side, I have sources that come into a SIM. So for example, you have logs and events from various sources. Um, in the security space, there is the need for context, which is related information to the logs, which give you some contextual information. For example, Active Directory or a configuration management database, which will tell you what devices you have and who owns those devices and things like that. And finally, you have intelligence sources, threat intel feeds, which tell you on an ongoing basis what is happening in the world out there, right? So there is concept of IOCs, which tell you bad IP addresses, bad hashes, things like that. And so that's another source of data into these SIMs. And in the data platform, there's a whole bunch of operations that are performed. So as you are aware, logs start out, again, depending on where they come from, they start out textual in nature, but these days logs are becoming more and more structured. But nevertheless, it needs to be parsed. It needs to be, every vendor calls their log fields something different. So there's a normalization process, a transformation process to get it into the SIM. There is enrichment. So I talked about context. So for example, if a log entry says an IP address shared or basically connected to a file share in a particular directory and moved a document, it would be useful to know what that IP address means. Is it whose laptop is it, and so on, right? So this is considered contextual information, for example, that you could get from your configuration management database, and user information from Active Directory. So the enrichment part of it kind of brings this together with the log, so that there's more context around who the actor is and what exactly they did, which could inform the analysis of that log entry. Then there are rule engines. That's you define what is a bad thing, like detection of what a bad event is, and so implementing that usually happens in the context of a rule engine. And then when bad things happen, you probably want to be notified. So you have an alert processor which either can send emails or log something or tell somebody, send some Slack messages and so on and so forth. Or at an advanced level, perhaps even go and auto remediate, where you say, go turn off, quarantine the host, and basically, the laptop can no longer make outbound networking connections and so on and so forth, right? But all of this is predicated on having a bunch of the data in your system. So there's indexing and query processing, which forms the underlying substrate over which enrichment rules and alerts are usually implemented. Now, as I mentioned, in the past, all of this used to be one system, but now we are seeing more and more disaggregation of this. So the data lake, as we call it, is being called out separately from the processing engines that do the work of the indexing and query processing, and then the algorithms for doing enrichment, rule engines, and alert processing is outside. And finally, on top, the way this is all surfaced to users is through dashboards for visualization or investigation. Threat hunting is an exercise that some threat hunting is about going through the logs, through the enriched logs, and finding new bad things that you were not aware of. And then, of course, machine learning and so on, so you can automate some of these processes. But then what's happening is this stack is usually connected with other platforms like Source or past or the data that you might glean out of the data analytics might be sent to a SIEM to do more things with this with the security data. So this is kind of the overall architecture of how one kind of assembles things to build a SIEM in today's day and age. And as I mentioned, a SIEM is basically, or a security data lake, is the place where a lot of different workflows come together. So um, threat detection is just about finding the bad stuff. So finding a needle in a haystack, looking for bad things that are happening. SOAR is a solution that is usually used for remediation. So you would basically take take action based on bad things that you've seen happening. Alerting is another use case for what's happening. Um, Correlation is not quite a use case, but it's an enabling thing. In the database world, what used to be called joins is in the security space called correlation. Um, a bunch of a lot of detection and threat hunting uses behavioral analytics, right? So, for example, in an organization, you might want to know what standard behavior looks like, or is it okay for somebody in marketing to be checking out source code from Git, right? It's probably an anomaly. So doing analytics like that is part of what the data lake assists with. So behavioral analytics is another signal generator into this process. Threat hunting, as I was mentioning earlier, is the ability to go in and look for more bad things that you may not be aware of. And then finally, providing visibility into what's happening inside your organization from a security standpoint. So what I wanted to do, I mean, the left side probably is worse than an eye exam, but my goal is not to kind of have you read that. I've expanded a part of that on the right, so I hope that is readable. But really what I wanted to show you was a few examples of workflows and what do they look like in a SIEM, right? So this is an example of a detection, and in fact, a very simple type of detection that we call single event detection, right? Which is uh, the idea here, I mean, so as I mentioned earlier, there are threat intel sources. In fact, a lot of threat intel sources are open source. This one is a specific intelligence document that I picked out from an open source threat intel service called Alien Vault. And this specific document talks about a vulnerability, or rather a an attack where somebody introduced malicious code into an npm repository, right? And that malicious code does a specific set of bad things. Now, the way detection is done, for example, in the single event detection world, is um, things are reduced to what is called IOCs, or indicators of compromise, right? Think of indicators of compromise as clues that you look for to say that this is how bad is defined. And what the threat intel document is saying is, if you find, I mean, this is just a subset of the IOCs present in this attack, but if you find a host name that looks like this, or a domain name that looks like that, or an IP address, or these specific set of IP addresses that something is reaching out to, or there is a file involved whose hash is that last line, if you can read that, right? So these are IOCs. So essentially, as you can imagine, all of these IOCs could be present in different actions that are performed within the organization, right? Like, for example, somebody does a DNS lookup for that host name. You want that data in the security analytics lake or the SIEM. Um, if somebody, again, as I said, the domain is looking up that domain, you want that information. If somebody is making a network connection to any of these IPs, you probably want to know that. And if you have that in the logs, a, a simple search for these tells you that there is an indication that uh, you might be you might have been might be vulnerable to this attack, or you have been compromised in some sense, right? So, but this is a very simple example from a search standpoint to find to implement with something like OpenSearch, because all you have to do is it's just a disjunctive query. It's a Boolean query which says look for this or this or this or this in all my data, and if you find it, notify. Right? This is a simple example of detection. Now, other workflows could be more complicated. So here is another scenario which is kind of a little more advanced. The scenario is an employee reports that a particular, I don't know if you've seen, but a lot of email clients these days have the ability for, like, Office 365 has a plugin where you could say, I received an email and this is a phishing email, right? And so an employee clicks on that and says, this is a phishing email. What happens behind the scenes could be something like this, which is the SOC analyst gets this notification that this is a phishing email. So first, they need to establish that it is indeed a phishing email. So you would probably want to check that email with respect to threat intel to know if there are any known IOCs in the email, right? So once they assert that that's a phishing email, there's a whole bunch of remediation steps you want to do. Because if this email came into one person's account, it's probably true that other people in the same organization got the same email. So what you really want to do is go and make sure that nobody clicks on that, and you clean it out. But if they have clicked on it, then there's a whole bunch of other sequences you got to do, right? So, for example, you might want to go see who else in the organization received that same email, move that email out of their inbox. If the email was opened by the user, but how do you know that? You know that because that email, because it's a phishing email, it probably made an outgoing connection to download a malicious, some malicious payload. So you know that from either your endpoint logs or your network logs. And if the file was if a file or an attachment was downloaded, then if that file was executed, then that is another signal, or there's one more step in the attack process that you need to now go address. And finally, worst case, you might want to quarantine the host. So as you can imagine, here this is like an investigation and remediation process that's multi-step, right? It's not a single search and you find the solution. Just wanted to kind of lay this out there to show you the different types of workloads that one needs to kind of implement on top of a security lake to be effective. Now, one of the observations, having gone through the process of using OpenSearch or Elasticsearch to build this, has been it's great on the, have the pros on the left, right? Which is one of the nice things about Elasticsearch or OpenSearch is you don't have to think about the schema. You can bring in the data. It's all semi-structured. Don't have to try to reason about what fields are called and so on, right? As compared to, for example, a relational database, which was how SIEMs were built in the past, right? So you would have to first define the schema, and then when you look for when you try to do search, you need to first say which field am I looking for data in, and what is the data type, and so on and so forth. With OpenSearch, none of that is true. You can bring it in, you can evolve that schema. So tomorrow you bring in new logs, or the product changes to generate new types of logs, you're covered, because the you don't have to kind of block the data from coming in. You can index all fields, right? OpenSearch has the ability to index all fields because you have no idea which fields for which log might contain an IOC. So you really want to index everything and say, can I find this IOC in there, right? Find needles in haystacks. That's what OpenSearch does, right? You give a search term, it finds you everything that contains that. One of the things, as you can imagine, in an investigative cycle is there's a person at the other end who is iterating over finding things, right? The moment you have an iterative workflow, you probably want low latency queries, which make it faster and more productive to use. That's another place where OpenSearch shines. And finally, especially in the multi-cloud world, there's a whole bunch of logs coming in. As if you're a multi-cloud organization, then you have logs coming into every cloud, and egressing logs into a single place is a non-starter, just because of egress costs involved, right? So what you really want architecturally is the ability to deploy something in each cloud separately, but have a uniform interface so you can federate the queries across those, right? And again, OpenSearch is great at that because it gives you it has this support for cross-cluster search, where I can push the queries down to multiple OpenSearch clusters and still get my results back. Now, the place where OpenSearch has drawbacks is, I would just talk about two, but the point is, first is, as I mentioned, correlation is important, being able to bring data that did not start out originally together, right? So you have some log coming in, but then you have your CMDB or configuration management database saying something about it. You need to be able to correlate across those two. That's not a great, it's not well supported, or it's actually, you cannot do that with the standard DSL that OpenSearch provides. And people have found out ways to kind of do this externally through writing joins outside of OpenSearch, or you need to ingest the data by denormalization, right? Like when you ingest the data, you essentially need to kind of do the correlations and then ingest the object all at once. The other problem is, in the security world, the amount of data that you need to keep, depending on, it's not just about data that came in today. You also need historical data, because you have no idea how far back you might have to go in time for threat hunting or even for detection, right? Because there are lots of attacks that are not point in time, but they're like attackers sit in your system for a long time and don't do anything, and then finally, they might act. So having to go back in time to find these needles is an important requirement. And one of the challenges with OpenSearch is how the cost scales with the amount of data as you increase the amount of retention in your system. So with that, what we have seen is like, I mean, if you look at a lot of security companies, the way they kind of build their products is they initially start with OpenSearch, and that works great for all the reasons I mentioned on the left. But then over time, they figure that they have a lot more data than they can afford to keep in OpenSearch, and so they start moving it into some kind of a data lake, right? Um, the challenge with this approach, I mean, this is possible if you have a bunch of engineers on your payroll, because from an application standpoint, now you have very different interfaces that you need to use to be able to query the data now, the last 30 days, which is an OpenSearch, and everything else, which might go back 13 months or 7 years, depending on your jurisdiction, sits in some other system, a data lake perhaps. And so now you're trying to build two interfaces for the same data for an analyst to use, or some kind of a layer to try to bridge the gap. What we have done at Mark V to address this problem is, actually we went the other way. We think that the OpenSearch API is actually very useful for all the reasons we talked about, how it helps kind of to bring security data and use it for all the security workflows that I mentioned. However, not all these systems provide an OpenSearch API. So what we have done actually is taken the OpenSearch API and built translators from OpenSearch into all of the different systems you see at the bottom there, right? So you could bring data into Amazon S3, or you into blob storage, cloud storage, Databricks, Snowflake, or BigQuery. You could use that as your data lake, but we make it look like OpenSearch from the top. So you can still use it with all the OpenSearch query DSL, uh, and get the same results that you would expect from OpenSearch. And the advantage of this approach is you can use cross-cluster search. So now go back to my previous picture where you split your data into those two pieces. Your application layer can still talk to OpenSearch or use the OpenSearch API, because cross-cluster search works across Mark V and OpenSearch and gives you a unified view of all your security data. So with that, I wanted to show you a demo of the product, with of how we kind of bridged OpenSearch on top of the data lakes and OpenSearch itself. Again, if you're familiar with OpenSearch dashboards, so here what I have is, just to quickly, so I have one table in this case. I have a few indexes. I have two indexes in my system. One index is in Google BigQuery, and the other index is in GCS, right? Google Cloud Storage. And what I'm going to show you is, okay, so this is my GCS data uh, GCS index. And so what I'm going to do here is, let me quickly show you. So this is, by the way, the UI that you're seeing is OpenSearch dashboards that we have essentially relabeled or as Mark V search. But really, this is stock OpenSearch dashboards, right? And so on the left here, let's see. So I have a few different indexes or index patterns here. So I have HTTP logs, which comes from GCS, and I have another index called OpenSearch dashboard sample data security logs, which comes from BigQuery. And I've created an index pattern that covers both of those, right? Star log star, which covers both HTTP logs as well as this. And so here, I mean, so I have no query at this point. And what you can see here is I have some amount of data that comes from my HTTP logs, which is in GCS. And there is some amount of data here, which actually comes from my BigQuery data. But what I'm going to do here is do a search for, let's say, DNS, which I know exists in both the places. So when I do that search, you will see, so here I see about 280 something records that came from GCS, from the GCS index. I mean, I'm telling you this because I know, but if I go here, you'll see this. So you will see about 60% of the data comes from HTTP logs and 40% from the OpenSearch dashboard sample logs. But really, what happened just now is the Elasticsearch or the OpenSearch query that you just that Mark V search produced was actually sent to two different indexes, one that lives in BigQuery and one that lives in GCS. And the BigQuery piece generated SQL to run this query, and the GCS part basically did a live search against the data in the bucket, in the GCS bucket, and brought the results back for the UI to process, right? So, but this is stock OpenSearch dashboard. So really, the API is what does that bridging. So now what I can do is I can have a unified view that across my 30 days of data in OpenSearch and how much ever you want in your data lake, and a single interface to actually query that, right? So this is how we actually bridge the gap to kind of bring a lot of security data and still not and be able to balance the costs of where the data is stored across OpenSearch and the data lake. Again, this, if you're familiar with OpenSearch dashboards, I mean, this is very underwhelming if you don't kind of know what's going on under the covers. But this supports all of the queries that OpenSearch dashboards would support or Elasticsearch would support. Thank you, everyone.